Number 19, or number 20 is different from 19 is because we have squared terms in them, so we definitely have a quadratic equation to begin with. One of the things I recognized early on is each of these has a factor of cotangent squared, so I'm going to take a cotangent squared out, so I'm using a monomial factorization process first, and that's going to give us a cosecant squared of x minus a 1 equals a 9. Now we have two places that we could use a Pythagorean identity here. One is with the cotangent squared, the other one is with the cosecant squared minus 1. And I'm inclined to replace this cosecant squared of 1 with a cotangent squared of x. Now we're equal to 9. Well, cotangent squared times a cotangent squared is a cotangent to the fourth of x equals a 9. To get rid of a power of 4, we do the inverse of that, and we're going to take the fourth root of both sides. So this is the fourth root of 9, and since it's an even power, it's plus and minus. Several of you have had some concerns with this one, so I said you could think of this as plus or minus the square root of 9, which is plus or minus the square root of square root of 9 is a 3. And this is what we'll have for our cotangent value. Cotangent of x is a plus or minus the square root of 3. So we're looking for an angle whose cotangent value, write it this way, x equals the inverse cotangent of a plus or minus the square root of 3 over a 1. It's the best way to look at it, so when you draw your reference triangle, you can see an x over a y value. So the reference triangle that I'm drawing is going to be in the first quadrant. Thinking about my plus and minus, I know I'm going to involve all quadrants because we have plus and minus values. Now I'm going to look at my reference triangle. The x value has to be the square root of 3. The y value has to be a 1. That forces the hypotenuse to be a 2, and that forces this to be an angle of pi 6. So one of the angles that would satisfy this equation is the angle pi 6. Now I want to get all the others in the second quadrant, which would be 5 pi 6. And I also want to get into the third quadrant, which would be 7 pi 6. And I also want to get the one in the fourth quadrant, which is pi 6 short of 2 pi, or 11 pi 6. Because I didn't square both sides as I did in number 19, I don't have to worry about checking those answers. If you had time, it would be wise, but that's typically all that we need to do to get all the solutions within one rotation.